I'm going to talk you through the exercise you had to do last week, which was 9.2 pattern sequences. This will just be an explanation video where I'll talk through how to approach the questions, and the answers will be on a document elsewhere, and you want to have a look at your answers and the actual answers. And if you get something wrong, then obviously related to this video, think about what you did and compare it to what I said to do. And if you still don't get something, then just ask, email me, message me on Teams. But that's the way you're going to find out quickest, is by asking. So in general, you're going to find a lot of information at the top here that isn't a question to answer, but might help you just get in the right frame of mind to answer the exercise. So it might seem like quicker to jump straight to question one, but if you have at least a read over this, then you're going to might find you save yourself a bit of time in the long run. So we're going to find patterns and rules and sequences, describe how pattern sequence grows, write and use numbers to model real life problems. This is sort of very current at the moment. About sort of the spread of a virus can be use a sequence to find out sort of how it's likely to spread in the future and how we can stop it. Fluency. So the 10th multiple of 3, the term-to-term rule of it, all these things are stuff you should already know, which is going to help you answer these questions. And just explore how long it takes a rumor to spread. That's just sort of getting you to think about things in a slightly different way. Okay, so onto the questions. Term-to-term rule. So we're going to understand term-to-term rule means how do we get from this one to this one? What do we do? So plus 6, plus 6, plus 6. This one's just plus 6, and this one's going to be plus 10. Nice and easy. Write down the next 4 sequences. So it's plus 4, plus 4, plus 4. So add 4 to get the next one, 21, 25, 29, and 33. Okay, nice and easy. Sequence has the first 4 term 4, and the term-to-term rule of -2, take away 2. First 4 terms, so the first term is 4 given to us, take away 2, take away 2, take away 2 to get the next 3 terms, and you'll be in the minus numbers then. Look at the pattern of counters. Draw the next pattern. So it's just a cross getting slightly bigger each time using an extra counter on each edge of the X. So just drawing out the next one, it would just have an extra counter on the edge compared to pattern 3. And then the table, you're just going to, pattern 1 is this one, just count the counters, 5, and then 9, and then we're putting 1 extra on each edge, aren't we? So it's adding 4 each time. So plus 4, but we can fill in the sequence, the table that way. Also, these hints are on the side, which is obviously a good place to go if you don't understand something. And then part C, describe how the sequence grows. Well, it's plus 4 each time, isn't it? We just talked about that. And number 5, look at the sequence of patterns made from squares. Draw the next one. So it's getting 1 higher and 1 longer each time. And so just draw 1 more on the top and 1 more on the side of the pattern 4. And we're just adding 2 extra squares each time. So it's plus 2, plus 2, plus 2, plus 2. Describe how it goes, it's plus 2. Question 6. Jack is collecting trading cards. He starts with a gift pack of 15 cards. He plans to buy 10 cards every week until he has 75. Copy and complete the table. And so the table, if we carry on the table, 10 cards every week, so an extra 10, extra 10, extra 10. So 35, 45, 55. Well, it's not going to quite get to 75. But next one, week 6, 65. Next one, week 7, 75. It's going to take him 7 weeks. 7 weeks to get his target. Okay, so some tables will have to just extend. Hint there says continue the table. Okay, right, then we've got some rectangles. So this is 1 by 2, then it's 2 by 3. Then if we can look at this one, it's 3 by 4. We can look at this one, it's 4 by 5. We can look at this one, it's 5 by 6. We can work out what they mean. So 3 times 4 is 12, 4 times 5 is 20, etc., etc. Describe new word sequence in your own words how the sequence grows. Well, what I'd say, the rectangle each time is getting one longer and one taller. So 1 by 2, it's getting then one taller and one longer, so it's 2 by 3. Okay, and then what will the 8th rectangle be? So the second one is 2 by 3, the third one is 3 by 4. Well, the 8th one's just going to be 8 by 9, isn't it? 8 times 9, 72. Finance. Abby and Ben are both saving up for a computer game that costs £40. Abby starts with £20 and saves £4 a week. Ben starts with £10 and saves £8 a week. Who will be first to have enough money for the game? How many ways are the solve this? Well, that's a discussion. If there's multiple people around, if we were in full class, we'd talk about how many different ways there are. It's probably several. You could probably just write out a list of what Abby has and what Ben has. You could write out a table. You could even create a formula, but I think creating a formula for this, it will definitely work, but because it's a fairly simple problem, it's probably not the most time efficient way of doing it. But if it was a more complicated problem, then a formula would be the most useful way of doing it. So let's actually look at answering the question. So Abby starts with £20 and saves £4 a week. So if you drew a table starting with like this one up here with number of weeks and cards, and then you have week 1, week 2, week 3, week 4 at the top, and then instead of number of cards, amount of money. So she's going to start with 20 and it's going to go up to 24, 28, etc., etc. And then do the same with, have another table for Ben. Ben will have 10, week 1 it'll be 10, and then 18, and then 26, and so on and so on. And just carry the tables on until you get to £40, and then see who gets there in the earlier week. And that'll tell you who's got the most money for it first. Okay. So, investigation. Potato in the middle of the tray has gone rotten. It's making the potatoes around it rotten, and then the ones around it go rotten, and so on and so on and so on. So if you copy this into square paper, you probably want to pick different colors, and each ring would be more and more rotten. And then just counting the different patterns, you get 1 and then 8, and then what would be the next one? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Okay, and then after that, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so it's going up a lot each time. And if you look at the way it's going, it's going to be, if you just carry on with the numbers, you can just count them, and it'll tell you how the sequence continues. And it's not like any other sequence, because it's just getting way bigger and way bigger and way bigger. Again, it's not an easy answer to what this is, but what this shows is exponential growth. The more bad things there are, then the more things they can make bad. And this is sort of how a virus works. If one person gets something and they're left to sort of spread it to everyone else, then they can give to lots of people, and then lots of people have it to give to lots of other people. And so that's how things work. And then we've got rumours, and I think that we don't need to go too much into that, because we obviously know rumours spread quickly in the same sort of way as sort of mouldy potatoes, in that you tell one person, they tell 3, and then each of those 3 tell 3, and before you know it, everybody knows. So they spread sort of quickly. Reflect. If we look at this, we can think about the diagrams we looked at, the tables and the lists of numbers, and think about which of those makes things clearer, because usually whatever the problem is with sequences, you could do one of these things. And if one of them makes this seem easier to you than the others, then perhaps you always want to look at that. Okay, so bear that in mind, reflect, have a think, and obviously check your actual answers with what I've just shown you.